Let's get the share screen. I wonder if I have to ask permission. Nope, I don't.
Nope, should be wide open.
Cool. Okay.
Hey, TK just joined.
TK's already seen this, so that's good. TK can critique.
Ask all the really hard questions.
That's right. He's studied up on it. Okay, so today I'm gonna do a series on MicroProfile, and but the first of this series is building RESTful services with JAX-RS. JAX-RS is kind of the core of MicroProfile. So first, who am I? You guys kind of already know me, but I'm a husband, have a wife. I live in Northern Kentucky, right outside of Cincinnati. I'm a father. I have 3 daughters, 22-year-old, 12-year-old, and 9-year-old. I am CTO at a small consulting company called Calibrity, which you'll see on the bottom of every slide, apparently. I'm an open source evangelist. I try to use open source technologies wherever I can. I've been a longtime member of the Apache Software Foundation, and I'm a movie quote master. I didn't know what to put there, but I'm always doing movie quotes all the time. I don't know why I'm able to remember those things, but it's like one of the only things that sticks in my brain. All right, so first of all, what is MicroProfile? So traditionally in Java, we've had like this Java EE thing, which basically says anything you want to do that's enterprisey, you have to have all of this stuff. So we have these big monolithic servers that you have to run your applications in that have all of these technologies. In order to be certified Java EE, you have to have everything, JMS, enterprise Java beans, all of these fun things. And then they started realizing that nobody wants these big behemoths to have to run and take care of them. So they started chunking the specs out. So taking little chunks of that Java EE thing and making smaller, what they call profiles. They had a web profile. They've got now they've had this MicroProfile. MicroProfile is specifically designed for microservices. So you see a lot of these things here are technologies that you need for doing microservices, where you have multiple services talking to one another, like the fault tolerance, the tracing, JWT propagation. Tracing is a big thing in microservices. So it's specifically designed around microservices, but the basis of it is all of these brighter orange boxes down on the bottom. These are kind of the base technologies. So what is JAX-RS? It is Jakarta RESTful Web Services. So Java EE has undergone a little bit of a transition. It's now owned by the Jakarta project. All the enterprise stuff is now owned by the Jakarta EE project. So everything's being renamed and rebranded. It's kind of a big mess. It was formerly the Java API for RESTful Web Services when Oracle owned it. Once it got to version 1.1, they included it in Java EE6 in 2009. And then it came out with a 2.0, which added some new cool stuff in 2013, and 2.1 added even more cool stuff in 17. Version 3 is just going to be, that's in September of this year, I believe. They're converting all of the package names over to the new Jakarta namespace. They're doing like, I think it's like org or IO, whatever. All the cool kids are doing IO. I don't remember what it is, but I think it's org. Org, Jakarta, EE, blah, 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 blah. And so that'll really just be same exact API, just different package names. And then 3.1, they're supposed to do by the end of this year, which will include some new features. And they're still kind of hemming and hawing about exactly what that's going to look like. One thing I want to point out is, and I have run into this at various places, but you know, the name says RESTful Web Services in it, but it's somewhat of a misnomer because it doesn't require that you use representational state transfer pattern or API style. You don't have to do that. You can do, you know, RPC style APIs if you'd like. You can do whatever you want, right? You can do streaming stuff, whatever, but it's built for like basically modern web service APIs. But for some reason they had to throw REST in there because that's what all the cool kids were doing back in the day, and it got people's attention, I guess. The first thing of a JAX-RS application is you have an application class. Now this isn't necessarily required, but it is part of the specs. I thought I'd cover it. And I added this in since Wednesday, TK. I didn't cover this on Wednesday, but I just kind of glossed over it. The application path up top, that basically says everything that's in this application is going to live under the /API stuff. And everything then, if you have any paths, they are going to go off of that API base path. The get classes is a way to tell the runtime about the classes that it can manage automatically for you. Get singletons is a way to actually hand them objects and say, I've already instantiated these things and configured them and wired them. You go take care, you go use them and do what you do with them. And then properties is a way of customizing the runtime itself with different features and stuff. By the way, since we're a small group and just ask questions along the way, feel free, no problem at all. So again, this is the application class. You'll notice whenever we do the, we exercise the API we're writing, you'll see /API. That's not magic built in. Every application has to look like that. It's just because of that annotation. So we'll start with the first resource class. This is what they call a resource class, right? So that's basically the service of your app. So the first thing is, in order to be a resource, at least a root resource, you have to have the @path annotation. Again, so this says, since we had the application before that said API, this says persons, so you're going to access this at API/persons. And since we don't have a path annotation on this say hello method, it's just going to be right on this root on the persons, and it's a get request. And we're kind of doing the low down dirty way of building the API by using the response and the response builder directly here. So the response class is kind of a generic, any response, but this gives you the absolute most control. You can do whatever you want with this thing. You can add the headers, you can do everything you want right here in this little builder thing. So this definitely gives you a lot of flexibility, but it's also a lot more verbose. It's like coding to the low level. It's like doing servlets instead of JSPs if you're familiar with Java. But we're setting the entity, the body of the response to be hello world, just like everybody has to. And then the media type is text plain, and building the response and returning it. Pretty straightforward stuff. Let's see if it works. I have a project that I'll share with you guys when we're done that has all these things in it, and where it runs is at localhost on port 9080. So I'm using HTTP. I don't know if you guys have seen that before, but it's a nice little utility. It's kind of like a modern day wget or curl. Not that you can't use curl today, but it's kind of oriented toward more like the JSON world that we live in today. So it kind of defaults everything to JSON. It makes dealing with JSON payloads very easy. So we're going to use HTTP, call the application, and it spits out hello world. We do see the text plain. We get a 200 response. That's where we built. We said, okay, that's what causes that. And the body's here, text plain. Cool. So the resource classes are your services in a JAX-RS application. As I said, the class level path annotation, and this one kind of threw me for a loop a little bit. I have always used, because I use an IOC container, as I said here, that the life cycle of the actual resource classes, they're just singletons. They stay around forever. They're application scoped, however you want to call that. But the default lifecycle per the specification is every time you call this, API /persons, it is going to instantiate that person resource class for every single request, and then it'll say, here's the thing I need you to do. And then once it's done with the request, it throws the thing away. It makes it eligible for garbage collection. So you can see there'd be a lot of churn, like your app, if you would look at like your garbage collection cycle, since it's doing that, instantiating everything it needs every single time, you'll see a lot of garbage collection going on. I prefer the more static approach where you instantiate everything at the beginning, and you don't have to do a bunch of instantiating and garbage collecting all the time. But you're doing it anyway. There's a bunch of stuff to garbage collect after every cycle. So I guess this is just another thing. It does support. Go ahead.
Is there, because I remember, I think you mentioned this Wednesday as well. And I was thinking, like, is there a performance consideration to that? Like instantiating everything all at the beginning versus like constantly having these sort of like spin up and spin down?
Yeah, I mean,
like
it's not relevant. For me, I think it's more of the psychology of the matter. I more prefer folks to do the hard work to make their stuff thread safe. That's the reason why they do this per request type stuff, is so people are like, well, I don't even have to worry about thread safety.
Right.
Well, it's kind of a crutch, in my opinion. I prefer to kind of bite the bullet, and I would rather code for safety always, as opposed to having to think, okay, am I in a situation where I'm doing request scope, so I can program this way for this, and then I would rather just always think about thread safety, you know, in my mind.
Okay.
But I'm old, so I've been doing this for a long time. But some people like the freedom it gives you to just not have to care about that stuff, and I can just all gets thrown away at the end of the request cycle. It'll go away. As far as performance is concerned, like I said, there is quite a bit going on as it's building up, you know, sucking out the information out of the actual HTTP request, building up a bunch of objects to embody that thing, and then handing it over to your resource class. There's going to be a lot of stuff garbage collected anyway, that just instantiating another object or a few or something probably isn't a big deal. So I don't think it's going to kill you too bad. And then we do support constructor, field, and property injection. So the methods that are going to be the things that fulfill requests for you, they have to have a request method designator annotation on it, and that's what these get, post, put, delete, blah, 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 all that stuff. You have to have that on there to tell it what it's doing. You should actually put path annotations on every method just so it's kind of explicit. I did not in the previous case, so it'll just default to the path of the resource itself, but it's probably better to just put an empty path annotation there just to be explicit. You can inject parameters into your methods. We'll see a little bit of that here later. The return type can be void, response, generic entity. I don't use generic entity. I don't know that I ever have. But you can also do custom types. So you can just create your own response objects that are whatever shape you want. And we'll talk a little more about that. You can also declare what media types you support, either with produces or consumes. Produces means here's what I spit out. Consumes means if you send me a body of stuff, I can consume it in this media format, which is like text plain, application JSON, that kind of stuff. So let's simplify the hello world example. We're back here again. No more response stuff. We're just saying, I want to return string, and then I just say return hello world. So this then becomes the body of the response. And we move the text plain declaration into this produces annotation on the method itself. Much simpler looking, much more straightforward. You're not having to build things up. One of the things about this that people don't catch on to very early is this also helps you have more of a kind of a self-documenting API. If all of your methods return response objects, when I go to, I've had the case where I've gone to another team and I'm like, hey, I need to use your service that, you know, whatever. And I was like, what does the response look like? And their answer was read the code. It's not a very friendly way to, you know, publish APIs for others to use if I have to go dig into your source code to say what are all the fields, and they were manually building up a JSON object, like instantiating like a map and putting fields in it manually. There was no API structures for me, so I would rather do it this way, this style, because it's almost self-documenting, right? So if I have a nice structured type that I'm returning, they know exactly what it is. So I would prefer this style. Okay, let's check out, does it still work? Yes, it does. No changes, 200, text plain, hello world. And the body, that string that we returned, that is known as the entity, as we said before. Out of the box, you get support for byte arrays, strings, input streams, all of these different things. A lot of this XML stuff. I was actually kind of surprised that I mean, I guess it makes sense that they would build it in, but they support all out of the box. You can do XML payloads, which nobody's using these days very much, right? Not in the modern web world. Behind the scenes, there's a lot of XML going on, but in the APIs, it's typically frowned upon to do XML stuff these days. You can pull in all of the information from your forms into a map, a multi-valued map of string to string. Multi-value just means that it's not mapping string to string, it's mapping string to list of strings. You can do a streaming output, we cover that later. And all of the primitive types and their wrappers are all supported. Cool. And by the way, we will show here, we're going to create our own model. It was called person resource for a reason. We were just using hello world as an example to get us started, but we're going to start using actual kind of like a real data scenario here. We're just going to provide a person service to the world. Here I'm using a tool called Lombok, L-O-M-B-O-K. And the at data at builder, all 4 of those annotations on the class, they all do something special. Data says, give me getters and setters for every property that you have here, do equals and hash code. So all of this stuff gets generated as an annotation processor at runtime for me, or at build time, I'm sorry, for me. The app builder gives me a way to just do kind of like a domain specific language fluid API builder. No args constructor, that's pretty straightforward. All args constructor, it will create a constructor that takes all 3 of these fields in the order they are defined. So I don't have to do all that. The best, and more importantly, I don't have to test all that. That's what I like it for. So let's check out our persons resource. We're just going to get a person, and here we're kind of hard coding, just building one, you know, out of the blue. I couldn't remember where I got Slappy White. Somebody asked me the other day where I got Slappy White. I had that name is stuck in my head, and I've used it in examples forever. Apparently, he was a comedian. He was on the Sanford and Son. Somebody told me. I was like, oh, cool. Well, I like Sanford and Son. So anyway, I've always used this name. But anyway, we're returning a person object from our method, and media type application JSON. That's kind of the web speaks this JSON thing, right? So we're instantiating it. We're using the builder as we talked about before, populating the fields, and we return person application JSON, and boom, we're going to check to see if it works. We get a 200 OK, application JSON response type, and we got all the fields that we set. Pretty straightforward, right? Pretty easy to read, right? Okay, I know it's going to return me a person object, and I can go look and see what that thing looks like, and even the API descriptor libraries that are out there, they can figure that out pretty well and spit out an open API spec for your API like that very easy. I don't have to write them myself at all if you use these bean type of approach. So in any web service, typically these days in microservices, you're dealing with things that are in a database, and the pattern that, you know, all the cool kids are doing since Eric Evans' book on domain-driven design is the repository pattern. So a repository really represents a collection of things, and with methods on there that allow you to either put things in it, get things out, delete things. It's just an abstraction. Typically, it's an abstraction over top of a database, right? But we're going to implement one in the example code. There's a memory-based implementation of this that just uses like a concurrent hash map in the background and keeps a collection of person objects. So we'll be able to add and find by ID using this person repository. So here we have our person resource again. Now we're starting to get into some of the other technologies that are included in the MicroProfile, and specifically the contexts and, that's a hard word to say, contexts and dependency injection, CDI. In order to declare this thing as a managed bean, I set it as type dependent. And I'm using constructor injection. I prefer constructor injection in most cases with these things. It makes testing much easier. If you can actually move this at inject into this field, then the field can't be final because somebody needs to write to it later after instantiation. But you can move this inject over here on this field, but I prefer not to do it that way, because if you have a private field that needs to be injected, if you're writing a test case, how are you going to get that thing in there? You got to resort to like a bunch of reflection mumbo jumbo and go start trying to figure out how to write things into these fields, or you have to instantiate the entire CDI context and let it do all the wiring for you automatically. But that makes your tests more heavyweight and harder to write. So I prefer this much simpler approach of a constructor-based injection. It's usually easier, and most all the IOC containers support that pattern. So just I'll get off my soapbox now, but that's why I do it this way, and I would recommend that. It does make your code much more portable if you do it that way. So the more important part down here, the same thing again, we're producing JSON, but we've introduced a path annotation onto this method, and we put this squiggly brace surrounded ID field, and that's going to be on our path. So if you do, again, /API/person/12345, whatever the ID is, this annotation with this little squiggly brace there to call out this field, along with this path param annotation. So this is what we call parameter injection on these methods. This ID right here has to match this, and that means basically I'm pulling the path param out of the request and pulling it into this parameter for me automatically, and so I can use it. There are other parameter injection mechanisms. You have stuff for cookies, headers, query parameters. I think we go over that here. Yeah, so you've got query parameter, which is after the question mark, matrix parameter, which is after the semicolon, header params, kind of self-explanatory, cookie, again. If you do submit a form to your application, to your resource method, you can actually pull out the form parameters, the fields that came in the form. And each one of these can have a default value. So if it's going to be null coming in, if there's nothing supplied, you can actually supply a default value and it'll use that instead. So at the query param case, you can do at query param subject, and you can put at default value equals Java. If you say, okay, if you don't tell me, I'm going to look for books on Java. Pretty simple stuff. The types that you can use are all the primitive types. Anything that has a constructor with a single string, so it's basically designed to parse itself out of a string parameter in the constructor, you can use those. If there's a static method with value of and from string, either one of those names will work. It needs to be public static, and it has to return the actual type that's matching, in our case, person. So if person class had a static value of. There is some crazy stuff in the spec around enum classes. It says that value of should be preferred over from string if they both exist, except if it's an enum class and then the from string. I don't know why, but that's what they did. But there's so know that there's some craziness around enums if you're ever writing these things. Well, for the most part, you don't run into that. So you can also add custom type support for your parameters. So for instance, if you had like a date, if you wanted people to pass in dates that are always going to be, like 2020, 08, 21, or whatever it is. I think it's 21st today. We're all from home right now, so I have no idea what date it is. But yeah, you could just take the string and you could always parse that into an actual date object. That's not supported out of the box. You could add your own param converter provider. We're not going to go through that because I've never used that in a real application. I've never really seen the need to do it, but I could see where some people might want to. Another case that might be like a UUID object, you might pass that in as a string, but want to parse it into a UUID. I could see that being an interesting case, but I've never run across it where I needed it. So here, let's call the API that we just created where we're getting stuff out of the database and persons 1, 2, 3. We got 204. So the method returned null. Automatically, JAX-RS is going to convert that to an empty body response with 204, no content. That happens automatically. You don't have to do anything. It just does that by default. Why is it null? Well, we were looking in our repository, but we never put anything into our repository. So there's a trick you can do in CDI as these kind of little initialization things. So we just write a little loader that adds Slappy White to our database automatically every time our application starts, just so we have some data, right? Not terribly important, nothing real JAX-RS-y about this. This is just a thing for us to always have something that we can rely on. The repository is implemented in such a way that it uses incremental IDs. So the first one's 1, 2, 3, 4. So Slappy White will be in there with ID 1 every time you start the app. So let's hit it again. And we see, again, Slappy White, application JSON, 200 OK, ID 1. All the things are as we would expect them to be. Any questions? It's pretty straightforward stuff. I mean, if you've written any of these like MVC type apps, they all kind of do very similar. Some will use annotations. It's kind of different ways to skin a cat, but they all kind of look and feel very similar to one another, and they all have a very similar way of handling things. And so, okay, so we're going to allow folks to create person objects in our repository. So everything else is still the same. None of the constructor injection doesn't change. I'm omitting the other methods just for brevity here, so that these slides didn't get crazy and the text didn't start to get crazy small. But the other methods are there. I just don't include them. So but we're adding a new method that's of type post. So we're going to allow people to post a payload to our method. And since I don't have any like at annotation here on this parameter, if you omit and you don't have any anything on this, it's going to assume that the body of the request needs to be parsed and turned into this thing, right? And by default, the in MicroProfile in particular, anything that any system that supports the JSON-B or the JSON binding API that's available, any system that has that supported, JAX-RS needs to automatically register converters and everything for that. So you get support for JSON out of the box, which you would think in anything for microservices that makes sense, right? So we don't have to do anything special. I just declare that the type is of the parameter type is of type person, and JAX-RS knows automatically parse the request that comes in, the body, into a person object and hand that to me. And we are going to return a string, which is the ID that is generated. The repository actually spits out, you know, okay, I added the person to the database, and here's the ID that I gave that person, and we return that in our response. So we're going to call HTTP post API persons. And the cool thing about, another thing about HTTP that's kind of cool is, like I said, it's oriented around JSON. So you don't really have to construct all the squiggly braces, brackets, and all that stuff to tell it this is JSON. You can actually just enumerate the fields if you have kind of a flat JSON object like we do here. You can just enumerate the fields and it'll construct the JSON for you. Again, it assumes JSON by default. You have to tell it otherwise. So here it knows, okay, the JSON should have a first name and last name field in it and fill in the values. So we're posting that, it returns okay. And it's doing application JSON response. The response is 2. The ID of Frankenstein here is 2. So let's go see if we can retrieve Frankenstein now with persons/2, and we can. We have the application JSON response type 200 okay. First name, last name, everything's like we would expect. Now, but we run into a snag. We got this guy on our team, right? Everybody's kind of smiling. Everybody's had this person on their team, and we get so pedantic about, well, that's not REST, you know, and that thing, how RESTy are things. That's not proper REST. There is no standard. So when people say, you know, proper REST, there's nothing really to go by. They're just kind of, everybody kind of agrees on certain things, but when you do a create, if you're creating something, technically, yes, you should return 201, which is the created response. So, you know, okay, fine. Since it gives me a way to do an example, I will go ahead and humor my friend here. That's actually, you know, we'll go ahead and humor this guy, right? And we're gonna do it. So, so we're creating a new annotation that'll help us identify these methods where we want to return 201 instead of 200. By default, we just get 200, which 200 is fine for most applications. If they're going to break because it says 200 instead of 201, something's wrong, right? Anyway, again, I'll get off my soapbox. The thing to pay attention to here is name binding. This annotation. This is saying that this annotation that's called created, it is intended to be a name binding annotation. What that means is I'm going to put it on a method. That's why I have element type method. And that is going to bind this method with a particular extension that we're going to add to JAX-RS here in the next slide. Or you can think of them like plugins, they're extension points. They call them providers in JAX-RS, and we'll see that here. One of the provider types is container response filter. This basically says, as the response is going back out to the client, I give you a chance to do things with it. There's a corresponding container request filter that looks very much like this, but the filter method that it declares only gives you the container request context. That's all you get. So on the way in, you can filter the requests and make changes to things. Folks use the container request filters for things like authentication, authorization, those type of things. But this is we're going to intercept this on the way out and change the 200 to a 201. Some things to take note. The application class, as we said before, you could tell it classes that it should know about or objects that it should know about. By default, I don't do any of that. Most of the runtimes are really good about doing scanning when you start up. And one of the things they look for is any class that's annotated with this app provider annotation. It's going to automatically detect these things and wire them into the system. In this case, though, if you don't have a name binding annotation on it, it's going to create this and put this filter on every resource and every method that's in your application. But we're scoping it up. We're using this @created. So we've added this @created name binding annotation to this plugin that we've created. That's basically saying only do this where I put this annotation. So, and the implementation is pretty straightforward. If it's a 200, change it to 201. Right? There's nothing fancy going on there. No rocket science. But the key things to take away are, you got to put, if you want it to be automatically discovered, you have to put this @provider, this @created scopes where it applies, and this is the interface of the thing that is the plugin type. So here we go. We're going to humor our friend, and we're adding the @created. Nothing else changes. Everything else is the same. I'm adding the @created annotation to that create person method. That's saying when you see this guy, please wire in this filter onto this method, and we are getting the 201. And the only thing we need to really pay attention to is this 201 created. It is going to return that, so we can make our friend happy now. Okay, so straightforward. Any questions? No. TK saw this the other day, so.
Well, okay, for me, I haven't seen JavaScript in like 10 years. I haven't seen Java in 10 years.
Okay.
And I'm just like, things have changed so much. Like, because I'm just seeing like Python closures, and what I'm liking so far is like, I feel like this makes it very hard to shoot yourself in the foot, you know? Like, instead of having to fiddle with various bits of machinery, like you have these, these tags, you could just, it takes care of doing this the right way. You just have to sort of like know what you want. And the API helps you construct that, which I really appreciate, especially when it comes to web dev, because it's very, very easy to shoot yourself in the foot. So I don't know. It's just been interesting though, because it just looks like Python now. I'm just like, what is happening? My world feels like it's crumbling down. Where's all the curly braces? This is Java.
Yeah, you bring up a good point. I know that Java's kind of got like a bad name in the industry right now, especially among the young crowd. They kind of, I don't know, Java is gross or whatever. And honestly, if you look at some of the older Java code that I wrote, oh my gosh, even a year ago, I might say yuck, right? But the language itself, since Java 8, has really started to tighten things up. Java is a very functional looking language. It's not fully functional. It's still an object-oriented language, but you can do things in a very functional way now. So it's a nice blend of the two paradigms. So you are definitely seeing a lot of that. There's a lot of things that have been introduced, and we'll show a couple more of these things that are more of the modern approach to Java. So I think what people might get that bad taste in their mouth about Java might be some of the things they're teaching in university. I don't know. Maybe that's where it's coming from. I don't know, but modern Java doesn't look like what some of the old stuff would have shown you. I mean, it is evolving very quickly. The newer versions of Java are coming out. We're getting close. It's on a path to have full support for pattern matching. And I don't know if you've ever used pattern matching, deconstruction kind of thing, right? That is going to be in the language Java. So Scala was the JVM language that gave us that, and everybody was like, oh my goodness, we've got to have that, right? So the new cadence of Java releasing every 6 months has really accelerated its path to becoming this very modern, very terse and readable language, right? And it is evolving to have full pattern matching support. We just got records, which we call records, which are really just like a data class that we just showed here, immutable data class. So they're building these pieces and releasing them in previews, and I really love the cadence. It's every 6 months we get these new goodies. And it's really helped, and the language itself is modernizing very quickly right before our eyes. So it's really cool.
Yeah, I don't want to deviate from your presentation too much, but this is almost something I want to talk about in like our regular virtual coffee, because like you said, there is a sort of like which languages are cool and which are not. And I always think, well, Java is still the most popular language on earth. Like according to the latest metrics, like Java, C#, and C++ are still like the big three. So, you know, even if you don't think they're in vogue, you should still know about them. And also, like you said, like, I feel like our opinions of languages are always like 5 years to 10 years behind what's actually going on in the language at the time. It's like people like, oh, Python's slow. I'm like, I don't even know if that's a relevant conversation anymore, but like stereotypes persist. I don't know
Yeah.
how we work that into the discussion one day, but it'd be nice for people to talk about their stacks and just kind of, you know, let the youth know that it, you know, it doesn't have to all be some flavor of JavaScript. Like everything else is still going on. JavaScript is still a baby in the grand scheme of things, you know?
Yeah, I think that if you want to label yourself as a, you know, full stack developer, most of the programs that are teaching full stack, yeah, yes, you can write full stack JavaScript applications, of course, with Node. But most of the stuff that's out there is either going to be a .NET Core type of, or a .NET application, or a Java application in the back end. Most everything that's out there is going to be like that these days, unless you're a startup where you get to choose whatever the heck you want and you can just start from scratch. Sure, that's cool. But if you're going to work at a bank, insurance company, any of these big companies that have a lot of money that can afford to pay you a lot of money, they're going to have some Java or they're going to have some .NET. So it is a good idea to, yeah, get familiar with that stuff. And if you want to be full stack, you're probably going to have to touch some of this stuff. So cool. But that's a good
I
perspective.
really like
go
like how I mean I've dabbled in Java, like just because preparing for a, you know, position that actually would have required me to know Java well. But it's nice, the transferability of even just concepts like restfulness. Like, you know, yeah, it's not a specification, it's really like guidelines, you know, everyone does the flavor a little bit differently. But it's interesting to see how even that knowledge set would allow you to be, I don't know, actually well prepared in another language. You know, it's interesting. And I feel like that's kind of a one way to, you know, knock some of those young whippersnappers into like, yeah, it doesn't have to all be JavaScript. The sun does not rise and set on JavaScript. Like, thank the Lord.
Yeah, I don't know. Like, you know, I've been around a long time. I'm 45, so I've been doing this a while. So, you know, I do have a preference for Java. I can see JavaScript. I can see the allure. I was talking, I think, the other day, and we were doing a demo when this talk was done, where I was showing the code, and some of the folks that are more like Ruby folks or JavaScript folks, I was like, well, yeah, it's cool. It can hot reload things. If I make changes to my code, it reloads it automatically. And they're all kind of snickering, like, well, yeah, no duh, right? You know, of course, JavaScript does that, and you know, but you know, Java we have to compile, and that's the developer experience in those situations isn't always the greatest. So it's cool when we have those sort of nice little luxuries that the cool kids have. So okay, cool. No, this is great discussion, and I do think that would be a good topic for like a virtual coffee. So okay, so we're going to use a different flavor of binding things to or plugins to methods. This is the more dynamic way of doing things. So we want to say, I want this request to be logged. So again, we create an interface for it, an interface, which means it's an annotation. And the one thing that we're leaving out is that name binding. That's no longer here, right? We're doing a different approach. So we're not doing the name binding approach. Another plugin type is the dynamic feature. So the idea here is you get to decide at runtime whether or not you want to add the plugin to this method, right? So the actual plugin that we want to add, the filter, there is request log filter, and that's down here, and we're deciding. Here's another one of those more modern Java things, TK, as we were talking about a second ago. This is from the optional class. This is, if I probably for explicit sake for a presentation, I probably should have done optional .of nullable, especially since I'm not including my imports. But this is actually a static import of this method. So this is actually optional .of nullable. So at the end, when you pass in the thing to this method, it spits out an optional object. And if that's null, it basically short circuits all of this logic. But if it's not null, then it'll go through the .map, blah, 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 right? So after it goes through .map, and we're saying, okay, get the value off the annotation, create a logger object from that with that name, using that name. And if it's still present at that time, I use the logger request log filter. So this is, again, like we were talking about, this is another way that Java has emerged as more of a modern language. We didn't have this .map stuff. It was if whatever is not equal to null, go do this, and then you would nest it again if not equal to null. We don't have Elvis operators errors and stuff like that, right? Okay, cool. So pretty straightforward. Now we do on our get person method, we do @logged, and again, nothing else happened. We didn't change anything else. And in our logs, now we start to see this. I didn't go and show the implementation of the logging filter, but you can kind of see what it would do. And it's included in the demo code that we'll show. But this is what we saw in the logs. Pretty snappy, 1 millisecond response. You would hope so. Using an in-memory database, it better be pretty fast, right? But we're just showing it's a GET request, the response code, and the reason, the textual description of what that response code is, and then we do put some timing around it. So cool. Now, with MicroProfile, we also get support for Java Bean validation. So when in our applications, typically, you want to make sure people aren't sending you bad data. You don't want to put bad data in your database. So we can actually use the Java Bean validation specification. Here, the two things you'll see are the not empty annotations here. I'm just saying, basically this says first name and last name are required. The not empty is actually two things. It's not null, and it can't be an empty string. So it finds both of those cases automatically. So we add that to it. And then to turn on validation, again, we use annotations for this, so it makes it kind of readable. We see our created annotation still there. @valid, we put that on the parameter. We're basically telling, hey, Java Bean validation, please jump in here and do your voodoo on this person object before you hand it to me, and make sure everything is up to snuff and all the fields are follow the validation that you've set, we've put on them. Nothing else has changed. All we added was @valid. And now if I try to send in an HTTP post request and I'm sending in a first name of oopsie, it is automatically going to spit out a 400 bad request. I didn't change anything about my code. No implementation changes happened. You just get that by default. If I put that @valid on there, it's going to spit out a bad request response. Again, it's an empty response, no content at all, but we do get a 400. So it's letting you know you're doing something wrong. This is a client error. It's a 400 level error. But that's not great API design, right? Like if you just return 400, I don't tell you what's bad. Like why is this a bad request? It's not great API design. So let's, again, another provider, right? This is another extension point for JAX-RS, and that the extension type is the exception mapper. What happens here is anytime an exception is thrown in JAX-RS, it maintains this tree, this hierarchy, right? Of just because the classes are in a hierarchy, and it's based on this parameter type here. In our case, it's constraint violation exception, but there's a tree, and it's looking for, okay, I have an exception of this type. It's looking in the tree, blah, 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 and it goes up the tree until it finds like the thing that is closest matching to your thing, right? Your type of exception that was thrown, and then it's going to hand that exception to the plugin that matches it. So in our case, it's constraint violation exception. That is what is thrown when the Java Bean validation API says this isn't going to work. So we're going to see these constraint violation exception objects. And again, we just return, I don't include it in the slides here, but there's an error response type. This is a pattern you'll see, and you probably should see in your applications. Whenever an error happens in an application, it's very good for you to include a standard shape. I don't know, some people refer to them as shapes, but it's a data structure, right? Some sort of just thing that you can rely on. If something goes wrong, this is what it looks like every single time. There's, whatever that you include in it. Some people include stack traces. Please don't ever do that. Some people do. Some people will put, here's the email of the people you can email to yell at about this problem. There's all sorts of approaches to error response design. People have varying opinions about it, but for me, I think that the key is every single exception mapper in your application should all return the same structure. Maybe they don't fill the whole thing out, but they all have the same basic structure that your clients can depend on. So what we're doing, we're just saying bad request, and the create error response method, it's in the code, but the idea is I just spin through the constraint violation exception, which has a list of constraint violations, and I just add error messages to the response object. Let's take a look at what it looks like. So now we're going to try to create a person with just first name. Oopsie. We get, yes, the 400 bad request, which is cool. The response is application JSON, and now we have a list of error message objects, which are just strings. And it's saying that that last name field must not be empty. Nice, a lot better, a little more verbose than what we had before, but you know, this is good design. I'm telling my caller, hey, you left out a last name. Maybe they fat fingered the name. They did all lowercase or something, but you get the idea. Okay, so I don't know if you ever use protobuf, but Google protobuf is a binary specification for interchange of data. We're defining a Google protocol buffer for the person class, for a person class, not the one we're already dealing with. We're adding a new one. What's going to happen here is protocol buffers, Google will compile this specification into some classes. It'll generate classes during build time. It's going to create a class called protobufs, and inside that, it will have an inner class called person. So, and it will reflect the specification in here. It's going to put it in this package, you know, all kind of pretty straightforward stuff, right? So we are, we're saying we are going to send back path ID proto. I didn't mess up our existing get by ID. I wanted to add this as an example to sit beside it so you could see it. I mean, automatically, I think I accidentally omitted the produces. I should have produces application proto buff here. I'm sorry. But it's, again, the of nullable thing kicks in. We're asking the repository to find us the object. If it's there, we map it to a more of the proto buff flavor of a person and return the response, right? Again, we still have the ID, but I just put /proto on the end. Now, like I said, JSON's built in by default. XML's built in by default. Protobuf is not. That is something that you have to add support for, which we'll do now. So this is another new type of extension point for JAX-RS, which is the message body writer. Anytime a body is going out in a response, a message body writer is responsible for doing that. In our particular case, we're saying we only support the message class, which message is the superclass of all classes generated by protobuf. So it makes it really convenient to write this thing. That's why it was a nice terse example. Probably why I chose it, right? It makes it super easy to limit what we're talking about. You put the app produces on there to limit, you know, what are the response types that I support. And then the is writable method, you can make decisions based on these other fields here about what you want to do. So it gives you a bunch of information. The type is the actual type. So for instance, if it was list of persons, here you would get a list.class object here. List.class would be the type. The generic type would be a parameterized type object that says list, and then with the parameter type being person. So you get kind of all this stuff handed to you so you can make decisions about how you want, if you're able to support this thing, right? Again, all these parameters are also sent to you here. The first, these 4 parameters are the same exact thing you would get here, but here you get to choose. Do you support this thing or not? If you say yes, then it's going to come back, turn around and say, okay, fine. Here, you write this thing out to this entity stream for me. You said you take care of it, please do. It's going to pass you the object itself, the message, and then all the other stuff that it had handed you, the headers, so you can modify headers if you'd like to, and then the output stream itself. Fortunately, again, this was a very easy one to choose. The message class from protobuf has a .write_to method that it'll just do all the magic for me automatically. I didn't have to write a bunch of mumbo jumbo in here. It takes care of that. So that makes for a nice terse example. And we'll see it in action. So we call the person/proto. Again, we get a 200 response. The response type is application protobuf. And we can see that Slappy White is returned. Technically, protobuf, like I said, is a binary protocol, but it spits out the information in a readable form enough that we can actually just see that it's working. But typically you won't do this. Now, protobuf is one of those things that I would recommend in between services. So for instance, if you have a service that's talking to the outside world, once you get in like through your firewall and you're talking to other microservices within your organization, in between those, protobuf is a perfect interchange format in between those because it's much smaller and it's much faster in coding than JSON is. It's really, really fast because all of the logic to do so is generated for you by the compiler, the protobuf compiler. So it's super fast. It's just actually doing native code at runtime once you've compiled that. So it's really quick. Definitely recommend it. The gRPC, that's the format that gRPC uses in between everybody is protobuf. This is an example of trying to limit the response type. So here I'm doing a get everybody method, which basically just says, hey repository, give me everybody that's in the database right now. And you can imagine at some point that could get really large. So in order to prevent that, we're adding this new annotation, zip it. Again, we have this get everybody response. It just has a person's field on it. As you can see here in the builder, it has just the person's field. So we're returning it, but we've added this annotation. We're going to use that name binding thing again, right? Here's our zip it annotation, has name binding on it. And we're introducing another extension type, which is the writer interceptor. Anytime something is written out, it's actually going through a pipeline. So anytime there's a message body writer in play, there's a pipeline or that happens where it goes through a bunch of these writer interceptors if they're in play. So it allows us to decorate the thing before it gets to the writer, right? The message body writer. We take the original stream, we save it off into a variable, we create a gzip output stream for that. And I don't know if you guys aren't familiar with Java. It used to be back in the old days, back in my day, we would have to do try. This little parentheses thing did not exist. There was no parentheses. You just put squiggly braces and you would do catch, blah, blah, blah. But the idea here is anything that's auto closable, you can put in this try, what this is called a try with resources block. So anything you instantiate here, when it hits this little squiggly brace, it's going to call the .close method on that for you automatically. We used to have to do that cleanup stuff ourselves. It does it automatically for you now in the language. That's kind of built in. It's a little syntactic sugar kind of thing, but it does make for a good quality of life. When you see this structure here, this try thing, this is called a try with resources block. So all these things are automatically closed. So anyway, we change the output stream on the context of the writer's context. So when it finally gets to the message body writer, the actual stream that it hands to it is going to be our gzip output stream. And then this context.proceed is kind of a funky thing. You have to call this if you want the thing to eventually flow through to the message body writer. This is saying basically the rest of the chain, go do your thing, right? And we are here then restoring the context's original stream after we're done. And like I said, this is try with resources, so it is auto closable. It will get closed and then finally will be called. So let's take a look at it. And we're going to call HTTP localhost API persons. Things you notice. Oh, I forgot to show. Yes, we added the header content encoding gzip. You guys probably already saw that while I was yapping, but I wanted to point it out. So you'll see that content encoding header is here, gzip, application JSON still, and we have two person objects here. So it did kick in and do the gzip encoding for us. Okay, any questions? Oh, okay. So there's a couple of patterns for doing asynchronous processing, reactive, whatever you want to call it, right? In JAX-RS. The first that they introduced is this notion of a suspended request. This is kind of a weird pattern. This is a get, but it returns void, right? And the reason is because I'm adding this async response object as the parameter type. So once it sees this and it knows, oh, well, you're going to be doing things asynchronously. Well, I don't care about your return type because it's going to be fulfilled with this object anyway. I don't have to worry about that. So it's basically handing you, okay, here's a way you can interact with me asynchronously to tell me what the response is. This gives you a little more flexibility around like things like we show here with timeouts. What this is saying is that, hey, after 10 seconds, just give up. Don't wait around anymore for this asynchronous processing to do its thing. And we set a timeout handler and say, once the timeout hits, here's what you do. And in our case, we just build a get everybody response with an empty persons list, right? There are no people in that case. So we wait around for 10 seconds and we just give up. And then the guts of it is this find all async is actually going to return like a future, right? So it's actually a completion stage. but it's a completable future object in the implementation. So it does find all asynchronously. So it's going off in another thread and doing this find all, and it's going to hand it back to us in a future. And once the future is fulfilled, then we apply a get everybody response constructor. So this is kind of a weird thing if you're not familiar with it. This is, and I probably should have explained it in a previous slide. This is a way to shortcut saying call the constructor of get everybody response. So get everybody response takes a list of person objects as it's a single parameter in its constructor. And you're just basically saying call the constructor. That's what this new indicates. And instantiate a get everybody response object, right? There's other ways you can actually call different methods. New is a keyword in Java, so no method can be named new. But if you wanted to call a method on something, you can do that also, like a static method. You can put that method name here. So anyway, that's what that is. Then we're taking the response object itself and we're calling on the whatever came out, which is a get everybody response. We are calling the .resume method, basically saying, hey, asynchronous response, we're done, we're finished. You go do your thing now, we're done here. And then you can also say exceptionally, when something happens that goes wrong on the response, I'm resuming with an exception. And then those exception mappers would kick in and start to map the response for us. And this is one of the weird things about Java's functional, because we're strongly typed in Java, we have to do these sort of weird things sometimes. So this response.resume actually returns Boolean. This exceptionally method takes a function that goes from throwable to void, capital V void, which is a type in Java. Since it's a type, we have to return a value for it. And in this case, I just return null. There's no way to instantiate void objects. It's just kind of a marker. But to satisfy the compiler, I had to return a null here. I know it looks a little funky, but it's to satisfy the compiler. So just a little Java-ism there. So that's what happens when you try to bolt on these functional concepts to a language that's been around for 20 years. Okay, so let's call our suspended method. That's what we call it, right? Yeah, path suspended. So let's call our persons suspended method. This is getting all the persons. It's still gzipped. We get application JSON and it returns flappy white. Questions? Nope, straightforward. So there's another cooler, I think it's cooler, way of handling the asynchronous processing in JAX-RS. And this is if you can return a completion stage object. This is completion stage is the super interface of completable future. That I think they realized that, but so if they didn't want to make you use completable future, they just wanted you to use something that adheres to the completable stage or the completion stage interface. So what you do is you just return something of that type or a subclass thereof, and it automatically kicks in and says, I know this is asynchronous. There's no other annotation here that says, hey, you got to do some asynchronous stuff here, JAX-RS. It knows because of the nature of completion stage objects. They are futures by definition. So I'm going to do this in another thread. I'm going to park this thing and hold on to this connection. And when this thing's finished, I'll go ahead and start writing the response out. So that makes it a little more straightforward, right? We're still doing the same thing we were doing before, the find all async and then apply, but I just have to return it at that point. I don't have to do any exceptionally. I don't have to do any resumes. I don't have to do any of that stuff. It does it for me automatically. Now, again, this kind of goes back to what we talked about earlier about API design and our classes. If I do an async response as a parameter, it makes it harder for people to understand what's going on, right? But here, they can say, oh, it's completion stage, so it's asynchronous. I don't really care about that, but I do care about the type, which is get everybody response. The other thing that's here is you can actually you can extract all of these JAX-RS methods, all the at, get, produces, path, all the methods that have these things on them. You can extract them out into an interface, a Java interface, which basically becomes your API definition. And you can take that interface now and put it in a jar file and hand it to your clients and say, if you want to talk to me, here's a very nice method of doing so. And there is the MicroProfile specification comes with the JAX-RS client API that you can build a client. It's a type-safe client API. You can say, here's the thing that the interface that this thing needs to implement. And it knows based on all of these annotations what all the requests look like and should look like. and you just point it at a base URL and say, give me a proxy at runtime that implements this class. And so it makes it really easy to talk to this thing, other people to talk to this thing. We'll talk about in another later part of this series about the MicroProfile. What is it? It's something, I don't know, whatever. There's the client API, but it's a strongly typed client API. That's the key. So again, let's call it with a future. Again, no surprises here. We'll get backslash UI 200 OK, gzip, application JSON. Nothing crazy going on here. This one's a little weird. We set up in one of the entity types supported was streaming output. This is kind of a callback mechanism. So I'm basically saying I return a streaming output object. One of the only method on there is, and I'm using the functional nature of Java. I don't even remember what the name of the method is off the top of my head, but I used these lambdas to define the implementation because there's only one method, so I just have to say what I do. So the idea is, here's the streaming output. It has a method on it that you can pass in an output stream and say, and I think it's like write output or something like that. So it'll pass me a stream back, and I take that stream and I write the data out. Okay. And the idea here, the reason that they introduced this is there are times when you might have a lot of data. For instance, if let's say each person in our database has an image for their profile picture, and maybe that's a 4K image, whatever, right? They're really big. I don't want to pull those images fully into memory every single time. So I might want to read them, chunk by chunk, 1024 bytes at a time out of the database, and then write them to this stream. So I don't pull the whole 4K huge image into memory and then write it out all in one big chunk. I can just read little pieces of it and spit it out to this output stream and just be done with it. And not have to pollute my memory with a bunch of information. Because you can imagine if, we had 1,000 requests at one time for big, huge 4K images, and our approach was to suck the whole thing out of the database and hold it into memory, and now I got 1,000 of them all at one time. So I'm tying up a lot of memory in those cases. So if you have those sort of situations, you can use this streaming output situation or approach to minimize your memory pressure. And again, looks very similar, the hello world, and these are kind of edge casey type things. This the asynchronous stuff and the stream stuff are kind of edge casey, but they're there. They're tools. They're nice little tools for situations where you might need them. So again, we've spit out hello world. And then the other thing that's another pretty cool thing that we have available out of the box is server sent events. I've always called them server side events, but it's server sent events, I guess is the technical name for it. But it does support it out of the box. You get this in, I believe, 2.1. JAX-RS 2.1 added it, but that's what MicroProfile supports. And since we're talking about MicroProfile, it will be here. One of the things to note here is this context annotation. This is the one of probably the more versatile dependency injection mechanism. So we have all the parameter injection stuff, but when you want to get like general purpose objects, different things, you can inject them with this at context. These two types of contextual objects are automatically supported. You can get those on these type of methods. If you do produces server sent events, these will now be available. And we just basically, the server sent event sync, the SSE event sync is a place where you can send server side or server sent events. We go through and get all the people and send them as events. This SSE is, the reason we have to inject this is we can't instantiate event objects directly ourselves. It's just an interface. This is an interface, this outbound SSE event. We need the runtime. Whoever is doing the support for server sent events knows how to instantiate the types of objects that it supports, and it knows how to talk to. So we use it kind of like as a factory, right? So this is similar to like JMS, Java Message System does the same thing. But we'd say, okay, SSE provider, please give me a new event with the name of the event is person, and I just put the full name as the data of the event, and then we send it to the sync. Again, we're using that try with resources trick here, right? So this sync object will actually be closed at the end of this little block for us automatically. Cool. Pretty straightforward. It's kind of cool. And I don't know if you're familiar with what server-side events is. It is not a bidirectional thing. It is a unidirectional. The server is saying, here's some stuff. I'm just going to trickle it out to you and send you some information. They're going to be events. And if it doesn't receive them, it reconnects and it can maintain a kind of a conversation with the server, except it's a one-way conversation. Kind of like my wife to me. I just, yes, dear, that kind of thing. So it allows you to send information kind of dynamically as they arrive. One of the things you can do with SSE, one of the parameters, and it's in the example code, shows an example of this. There is a header that's part of the spec that says the ID of every event has an ID, and you can say the last ID that I received from you was this, and the client will send that. There's actually a JavaScript example, a little HTML. Yes, I can code in JavaScript, or at least copy and paste examples from Stack Overflow with the best of them. It just will download all the person names and spit them out to the screen on the HTML example that we have in the code repository. But you will see that it's passing back and forth that here's the last ID that I've seen from you. And then we use that to determine, okay, is there anything new that comes after that ID? So anyway, that's just server sent events in JAX-RS. Okay, any questions?
Not necessarily for me, but I've loved this just from the perspective of I've gotten to see things that I would normally have like seen kind of like in the full context of an example, just
Okay.
for me learning something online. You know, I was able to relate through RESTful, through, you know, obviously full CRUD. It was still very, very valid for me as an example, as a lesson.
Cool.
I'm going away with a lot more than I thought, and that sounds so horrible to say.
It's okay. It's Java. The expectations are low. I can knock this stuff out of the park. You know what I mean?
Yeah.
Chad, how
Thank
about
you.
you? I know you jumped in late, but were you able to pick up anything?
I mean, I guess because I was kind of late, one of the things that I was kind of interested in is just kind of like how it's set up, kind of like a promise in JavaScript. I don't know
Yeah.
if that is actually unique to JAX-RS, or I just happen to miss, because I'm in Jamaica, so I missed this by an hour. I was like, oh, 9 o'clock, I'll come in at 9, and of course it's 9 now.
We are recording it, so you can like go back in
Yes.
time and watch yourself talking to me. That's going to be really cool. It's like Back to the Future, right? Yes. So that notion of promises, you're exactly right. So JavaScript has promises, and Java has what they call the future. So that it's kind of the same notion. Though I'm going to go do something, and at some later time, I'm going to tell you I'm done with it, and you get an opportunity to do whatever you do when I'm done.
Right,
But
right.
don't do it in line. That's the idea. JavaScript itself, Node is built on that concept. But that is available in Java. And when we did the this thing, so this completion stage thing, yes, it's exactly what it is. It's like a promise in JavaScript. But the implementation is, and you see in the example code, there's a class called a completable future. The notion of promise in Java is kind of referred to as a future. That's kind of our native structure for the same sort of concept.
Right. I guess since I'm a little bit late, so from what I got when I came in, it's primarily JAX-RS is primarily for like dealing with asynchronous calls, but not necessarily sending all of the data at once. Like it will send like chunks of data. I know that's one of the things that you were covering, but I'm not sure if that was the primary use. So, and I mean, I'm just kind of catching up. So
No, that's totally fine. No, so I think the overall, if I had to get it, it's more like it's just for writing web services in general, right? So you don't have to necessarily do asynchronous processing, but it's built in. It does support that, but it's more or less, this is your toolkit for writing web services in Java. Most of the kind of vanilla examples you'll see are not asynchronous. Those asynchronous examples are more of an advanced thing to put a tool to have in your tool belt. But they do come in handy for sure. You know, I mean, especially if you're in Node and you're used to that method of, you know, everything's dynamic, that will just come second nature to you. If you're into that callback hell thing, I'm just kidding. But that's what the Java folks say about JavaScript. I'm sorry, that was ugly. That wasn't very nice. But yeah, you can get into the very exact same callback hell in Java with those futures. It can start to look very much like the callback hell that you've seen, and we've worked around in the JavaScript world. They have better libraries for that. But yeah, so it's the same idea. But again, that's just more of it on the advanced side that your APIs don't necessarily have to do that, especially if they're short, right? They don't do a whole lot. You could just write them as vanilla.
Oh, okay. Okay. How does this compare to Spring? As that's the only other thing I have.
Oh, that's a great question. So Spring MVC, when you watch back through this video, see how I said when? I'm already signing you up to watch it. You know what I mean? So when you watch back through the video, you'll see the API kind of stuff, especially if you're familiar with Spring MVC. It's very similar. The one thing that's different about Spring does at get request. So they have one annotation that says this is a get request and here's the path. The way JAX-RS set it up, because the request method designators, the get, post, put, all of that, those are extensible. You can write your own custom verbs, right? You can't do that very easily in Spring MVC because you have to include all of the other stuff that comes with that. So all the path and all the other pieces of those annotations. But with JAX-RS, you just have to create another get, post, put, one of those things. And then the path mapping is all only done with the path annotation. So in Spring, they kind of munge those two concepts together of path mapping and request method designator. In JAX-RS, they split them apart. So you will have two annotations a lot of times on your method. You'll have the method designator, get, post, put, whatever, all that stuff, delete, and a path mapping to say how does this request come in and how do I match it up with my method. But the overall concepts are very, very similar. And this stuff's these concepts have been around for a while, and a lot of the libraries and all the different languages kind of do very similar stuff. We were talking about that before with TK when he was on. But
can I interject a question?
Yep.
About those annotations. Is there a specific order that they need to be included in? Are they read in a certain order? Is it like bits of information that needs to be provided in a certain order? I noticed you followed a similar construction theme all the way through when you were writing, but does it matter necessarily, like the order for which you listed the several annotations in a row?
It does not. They really are just added on as like a set. The one thing that's,
okay.
You can't have duplicates, right? They won't allow that, but
yeah.
Typically you'll have these like, some annotations can be duplicated, but typically what you'll see is like if you have a thing that you want to put multiple of them, they'll have a pluralized flavor of that annotation, and then inside that you can have a thing that lists, the fields. But no, there's no real order required to that. I tend to follow, like you saw, the get is first, and or path.
Yeah.
I don't even know. I don't even know what my. I have to look at it. What I follow. Yeah. Okay. So get, path, produce. Okay. So that's kind of the way I do it.
It was pretty logical. Like you would want to read it in this order, to like human process it. But I didn't know if like that was like required to be written in that fashion. I mean, there's many languages where like this must be on line 1, it must be written this way, and I wasn't sure if like willy-nilly annotations, throw them in there, or if it was like, nope, they got to be structured in a certain way.
It doesn't, but now I don't know if I just do that myself, like because I follow it that way, because it does read really nicely. I like the way you put that, like get, here's the path, here's what it produces. Okay. But no, it's not technically required, but yeah, maybe I just do that. My brain makes me do that. I never paid attention to that. That's an interesting observation. That's cool. Cool.
So the other question that I have is generally Java is done for like enterprise applications. Would you say JAX-RS would be kind of geared towards that same type of like usage?
I don't want to get on a soapbox, but I would maybe take exception with the fact that Java is, kind of just go over here and do enterprise stuff and leave me alone. I can't do rapid application development and, startup-y type stuff with Java. I would take exception to that just because I'm a person who's been doing Java for 20 years. I can see how it might not be as approachable to folks just coming out of school or whatever. Right? So
I just don't know. So like, I'm just asking because that's what I heard.
No, I wouldn't say that that's a fair characterization, that it is only applicable for enterprise applications. I wouldn't say that's fair, because I've written both types, like microservices. I think I wrote an entire microservice that had like 30 lines of code, you know, like in Java, and so you can do it. It's not, that's one of the things that we were talking about earlier, is Java has kind of a bad name for being very verbose. The one thing that's cool about Java, that some of that verbosity is on purpose. It's designed for readability first and foremost, because most code is written to be read. It is not written to be written. A lot of people focus on, well, I have to do so many keystrokes. That's not what you need to optimize for as a professional in this industry. You need to optimize for, it ain't about right here and now what I'm typey on my keyboard. That's not, most of the time spent on a problem will be up here. Even before you put your hands on the keyboard, most of the time's up here, right? So putting your hands down on the keyboard, you're not spending a lot of time there anyway, but primarily it's the future self. It's the person who's going to have to wake up at 2 in the morning when everybody's hair's on fire, the CTO's on the bridge line with everybody yelling at everybody saying, you're fired if you don't get this fixed. Hopefully they don't say that. But that's who you're writing your code for. And if it's very terse, and I have to kind of think and like, okay, what was I doing here? But that's Java's mindset, is readability first and foremost. They want to maintain that readability. They're trying to keep it from getting to the cutesy level with too much syntactic sugar. Yeah. They don't want too much of that stuff in the language that it starts to lose its readability. So that's why they will maintain the verbosity, and they will make no bones about it, and they won't apologize for it. The designers of the language, they will say that we want this in there because we want it to be readable.
I actually think that's one of my attractions to Java as a language, is its verbosity. And maybe that's just my, odd duck perception, but refactoring is great, but you shouldn't refactor to the least number of lines. For me, that's not the goal. You need to refactor for, general performance and efficiency. Great. But if you need 7 lines of comments to explain what this single line of code does, it's like, have you just shot yourself in the other foot in refactoring? It's like, you're not getting anywhere. Now you're on the other foot. And I think the fact that, with Java, it is so verbose that, that's a feature for me. That's great, and especially as someone learning, it's great because things aren't hidden, like in React, with hooks, like you could use hooks very easy, but there's so much stuff going on behind the scenes that you don't understand a lot of the underlying, reasons, understand component lifecycle. You can't just look at an example in code going, what the hell's going on? I've actually never had that problem with Java. Like I was able to walk through every example you showed me, and I couldn't write it. So for me, that's the nice part.
Yeah, and that's the thing I think that we're missing because there is an art to what we do, right? I mean, we're creative folks. We're techie nerds, but there is an art to what we do, and part of that art is telling a story. You're telling a story to your reader. That's who you're telling the story to, is the people who are waking up at 2 in the morning and things are, everybody's hair's on fire. You're telling a story to them. And I would strive to make your code as readable as possible. Don't worry about the keystrokes. Keyboards are cheap, right? I mean, you can get a keyboard for $40. Like I'll get 100 of those a year if I have to, if it means that I can read my code later on, right? I'm not worried about optimizing this thing, right? I don't care about this thing. I care about this thing. Mm-hmm. This one's expensive. Well, not really, but
$55 at Best Buy, man. It's great.
Yeah. No, this is great stuff. I appreciate y'all letting me practice my talk again. I've been doing JAX-RS for many years. This is the one I use even in Spring Boot. When I do Spring Boot apps, I will use JAX-RS as the web technology and not use MVC. Mainly because I can use JAX-RS in an OSGI application. I can use JAX-RS in a CDI-based application. I can use JAX-RS anywhere. It's portable, right? It is the standard for web development in Java. Spring MVC is not the standard, right? Again, I love Spring MVC. It's great, but if I want my code to be portable and the more I use it, if I'm in OSGI, I'm using JAX-RS. If I'm in the CDI, I use JAX-RS. If I'm Spring, I use JAX-RS. The more I use it, the better I get at it. I'm good at it when I keep using it over and over and over again. I get really good at something, and there's something to be said for that. You can get very productive with that.
Yeah,
cool.
This is great. Thank you, and I look forward to many future talks that you give. So please continue. I encourage you.
Yeah, let's see. I think I had another. Oh yeah, I had a thank you slide, and you all already follow me on Twitter. I think both of you, but do. But my Medium account is at the War on Bugs. So if you ever want to, I've posted a couple articles, but I'm working on that. I'm going to start doing a lot more writing because I actually enjoy it.
Good. I think writing as developers, it encourages good communication and across all fronts, you know.
Absolutely.
Keeps us humble to some degree too.
Yes, absolutely. Cool. Well, thank you again for attending, and thank you for letting me yap at you.
Always.
We'll see you all.
See ya.
Have a good one.